Hello everybody and welcome to lesson 2.7. We'll continue with absolute value, but this time we'll be solving absolute value inequalities. So just like with absolute value equations, we're going to have two solutions. So again, you want to isolate the absolute value if needed. So if a number, if it's on the same side as the absolute value symbol, then you'll need to add or subtract it over to the other side if it's not inside the absolute value symbol. Then you'll do your case 1 and your case 2. Case 1, again, you'll just drop the absolute value symbol and you'll solve. Case 2, since we're working with inequalities, we drop the absolute value symbol, and since we're converting the right-hand side to a negative, we also have to flip the inequality symbol and then solve. Okay, so let's look at some of these. Okay, if A is positive, so if the number to the right is positive here, and you have the absolute value of something that is less than that number, then this will be considered your AND inequality. So if you have the absolute value of X or absolute value of whatever and it's less than a number, it's going to be your AND inequality. That's how you're going to treat it. So if we have the absolute value of X plus 4 is less than 6. We're still going to have our two cases. Case 1, you simply drop the absolute value symbols and you solve the inequality. So in this case, we would subtract 4 to come out with X is less than 2. Case 2, you drop the absolute value symbols, you flip the inequalities, and you make this number over here negative, or you change the sign of that number. Okay, and then you will solve it by subtracting 4, and you come out with X is greater than negative 6. Now this is an AND inequality. It's an AND inequality. So you still will need to write your answers in interval notation. So again, to help you out, you might want to graph the inequality. So we have X is less than 2 and X is greater than 6. So let's look and see how the graph would look for X is less than 2 and X is greater than negative 6. So we have 0 here, negative 6 out here, and let's say 2 right here. If it's greater than 2, that means it's going back to the left from 2. I'm sorry, if it's less than 2, that means it's going back to the left from 2. And if it's greater than negative 6, it's going to the right from negative 6. Now we don't have the equal to bars, so we would use parentheses on each one of those. And we would shade in between negative 6 and 2. That's where our solution would be. So the interval notation, parentheses, negative 6, comma, and it goes to 2, parentheses. Okay? So again, if it starts off with the absolute value of X is less than a number, then you treat it as the AND inequality. Okay? So if we have the absolute value of X minus 3 plus 6 is less than or equal to 7, before we can do our case 1 and case 2, we need to subtract this 6 because it is not inside our absolute value symbols. And we get the absolute value of X minus 3 is less than or equal to 1. So again, its absolute value of X is less than, so this is going to be an AND inequality. So now you would do your case 1 and your case 2. X minus 3 is less than or equal to 1. Add 3 to both sides to solve it. X is less than or equal to 4. Again, with case 2, the left-hand side stays like it is, X minus 3. You flip your inequality symbol and you change the sign of the number on the right-hand side. So that becomes negative 1. Then you add 3 to both sides and you get X is greater than or equal to 2. So again, it's an AND inequality. It says that X is greater than or equal to 2 and X is less than or equal to 4. And again, we want to write our answers in interval notation. So let's look at the graph. and look and see how we would write that in interval notation. So it's greater than or equal to 2, and it's less than or equal to 4. And remember those and inequalities, you may also see those written like that. Okay, so let's look at the graph on this. So we have 0, we'll call this 2, and we'll call this 4. Again, this time we have the equal to bar underneath it, so we will have brackets on each one of those. If it's greater than 2, that's going to the right from 2, and less than 4, that's going to the left from 4. So the shading would be in between the two. Interval notation, remember that goes from left to right, so we'll have bracket 2, comma, 4, bracket for our interval notation. Okay. All right. All right. Let's say we had the absolute value of 8x minus 3 is less than negative 2. Now again, from the definition of the absolute value, you know once you take the absolute value of anything, you end up with a positive answer. So you cannot take the absolute value of something and it be less than 0. So if this is said this is less than negative 2, that's impossible. So our answer for that would be no solution. You cannot take the absolute value and it be less than a negative number. Remember, every time you take the absolute value, your result is positive. So it's no solution for a problem like that. Now, before you determine whether it's no solution or not, you need to make sure that your absolute value is isolated to one side, and then determine whether it will be no solution or not. Okay? If we have the absolute value of something that's greater than a number, this is going to be your OR inequality. Okay, so let's say we have the absolute value of 10 plus 3x is greater than 1. You're going to solve these the same way. So we'll have 10 plus 3x is greater than 1. So we'll solve this by subtracting 10 and dividing by 3x. So we get 3x is greater than negative 9. Divide by 3, divide by 3. X is greater than negative 3. Case 2, left-hand side stays the same. Right-hand side, you have to flip the inequality symbol and change that sign. So it becomes less than negative 1. Subtract 10, subtract 10. Get 3x is less than negative 11. Divide by 3, divide by 3. X is less than negative 11 thirds. And that's about negative 3 and 2/3. So let's look at the graph for this one. Greater than negative 3, less than negative 3 and 2/3. Okay, so we had greater than negative 3, no equal to bar there. And then we had less than negative 11 thirds, which is the same thing as about negative 3 and 2/3. So we have 0, we'll call that negative 3, and then we'll, right there between negative 3 and negative 4, we'll call that negative, put it over here. Let's redo that graph. Okay. Okay, so 0, we'll say negative 3 there, and then negative 4 out here. So we'll say negative 3 and 2/3, or negative 11 thirds is right here. All right, so we're greater than negative 3. Parentheses, greater than would be to the right from negative 3, there. Or we're less than negative 3 and 2/3, less than negative 11 thirds, parentheses here, to the left to make less than. Interval notation, remember you start from the left and you go to the right. This is negative infinity out here. So parentheses, negative infinity, comma, stop at negative 11 thirds. And then you have to union, since it's a space here, remember we use that U symbol, union, start at negative 3, goes to positive infinity. Okay, so that's how your graph, and then that's how your answer should look in interval notation. Okay. All right, what about the absolute value of something that says it's greater than or equal to 0? Well, remember when we take the absolute value of anything, we get 0 or greater. It's always 0 or is greater than 0. So since this is always true, there's no need to do any work for that. It will be all real numbers. Because every time we take the absolute value of something, we get 0 or greater, and that's what it says here. So our answer will be all real numbers. Interval notation for that would be negative infinity to positive infinity.